Hi everyone, let's take a look at the following limit. Limit of 2 to the power of x minus 8 all over x squared minus 2x minus 3 as x is approaching to 3. Now before we start with step 1, think about limits. There's so many rules you want to keep in mind. For example, you want to find the left limit, find the right limit, and if they equal to the same number, then there is a limit which equals to capital L, which is basically the number or the final answer. Or when you go through limits, think about the first step. Plug in x to be 3. So in this case, if you plug in x to be 3, that's going to be 2 to the power of 3 minus 8 divided by 3 squared minus 2 times 3 minus 3. If you work it out, again, you can take your calculator. I'm going to go through some mental math. 2 to the power of 3, that's going to be 8 minus 8, that's going to be 0. If I look at the denominator, 3 squared is going to be 9 minus 6 minus 3, that's going to be 0. And you end up with one of the 7 types of indeterminates. Again, the most common 2 types are 0 divided by 0 or infinity divided by infinity. Now, normally, when this happens, you can move on to factoring, you can move on to multiplying the top and the bottom by its conjugate, and so on. But in this example, I would like to show you a rule called the L'Hopital's rule. So in a different color, let's write this out. So this rule states that if you're looking at the limit of x approaching to a, so if there's a limit, and this function could be expressed as a fraction, so let's say a function f of x divided by g of x, and you end up getting either 0 divided by 0, which I'll put in quotation marks, or infinity divided by infinity, then you have to take the derivative of the top and the bottom. So you take the limit as x is approaching to a of f prime of x divided by g prime of x. And you have to try again. So once you find f prime divided by g prime, you plug in x to be a. If it works, excellent. If it doesn't work, and sometimes you have to apply L'Hopital's rule multiple times, you do it again and again and again. Let's write down the name. L'Hopital's rule. Now, and it's not enough to memorize the formula. Let's apply this. So limit as x is approaching to 3, you're going to take the derivative of the top and the bottom. Now, there are a lot of different rules you have to remember. What are the rules? And I'll write this down for you, just in case if you forgot. When you find the derivative of 2 to the power of x, what you're thinking about is this. When you find d by dx of a to the power of x, this equals to a to the power of x times ln of a. And of course, you can apply the chain rule if it's a to the power of f of x. But in this case, we can use this formula, 2 to the power of x times ln of 2. Now, don't forget when you differentiate a constant, just such as negative 8, that's going to give you 0, divided by, when you differentiate x squared, that's going to be 2x. When you differentiate negative 2x, that's going to be negative 2. Again, when you take the derivative of negative 3, that's going to give you 0. Now, we go back to step number 1. You plug in x to be 3. 2 to the power of 3 times ln of 2 divided by 2 times 3 minus 2. Now, I am going to leave this in exact form. I'm also going to give you the approximation to 1 decimal place. So 2 to the power of 3, that's going to be 8 times ln of 2 divided by 2 times 3 is going to be 6. 6 minus 2 is going to be 4. So this really equals to 2 ln 2. Again, if you take your calculator, turn it on, press clear, 2 times ln of 2, it's going to be approximately 1.386294361, or approximately 1.4. Now, most students would stop here. They found the limit, it's good enough, they leave good enough alone. but we're going to go above and beyond. Let's over deliver by double checking. This is Desmos, and all you have to do is graph the function. So 2 to the power of x minus 8 divided by x squared minus 2x minus 3. Now what you have to do is hover over x equal to 3. Now, as expected, the answer should be undefined. Right there. Do you see how at 3 it's undefined? And again, we knew this because we found 0 divided by 0 from step 1. Again, that was one of the 7 types of indeterminates. Now, if I circle back to the beginning of this video, I've talked about the left limit and the right limit. When you're approaching from the left, notice as you get closer and closer to 3, this is roughly 1.4, exactly what we found algebraically. Likewise, if you're approaching it from the right, as I'm getting closer and closer, all the way to 3, again, is approximately 1.4. So the left limit and the right limit is the same, and it equals to 1.4. I hope this makes sense.